Hello, welcome to the session on Introduction to NLP. By the end of this session, you will be able to understand about NLP and its importance. We will look into its working and see phases involved in NLP. We will also learn about its techniques and approaches as well as its tools and libraries. Other than this, we'll look into its applications, advantages, and challenges of NLP. Now let's start the session. NLP stands for Natural Language Processing. Natural Language Processing, NLP, is the ability of a computer program to understand human language as it is spoken and written, referred to as natural language. It is a component of artificial intelligence, AI. NLP has existed for more than 50 years and has roots in the field of linguistics. It has a variety of real-world applications in a number of fields, including medical research, search engines, and business intelligence. NLP drives computer programs that translate text from one language to another, respond to spoken commands, and summarize large volumes of text rapidly, even in real time. There's a good chance you've interacted with NLP in the form of voice-operated GPS systems, digital assistants, speech-to-text dictation software, customer service chatbots, and other consumer conveniences. But NLP also plays a growing role in enterprise solutions that help streamline business operations, increase employee productivity, and simplify mission-critical business processes. Now, when we know what is NLP, let's see why is it important. It is important because NLP enables computers to understand and interpret human language, bridging the gap between human and machine communication. It allows for automation of tasks that require language processing, leading to increased efficiency and productivity. NLP has applications in various domains, including customer service, healthcare, finance, e-commerce, and more. Now let's dive into its working. NLP enables computers to understand natural language as humans do. Whether the language is spoken or written, natural language processing uses artificial intelligence to take real-world input, process it, and make sense of it in a way a computer can understand. Just as humans have different senses, such as ears to hear and eyes to see, computers have programs to read and microphones to collect audio. And just as humans have a brain to process that input, computers have a program to process their respective inputs. At some point in processing, the input is converted to code that the computer can understand. There are two main phases to natural language processing: data pre-processing and algorithm development. Data pre-processing involves preparing and cleaning text data for machines to be able to analyze it. Pre-processing puts data in workable form and highlights features in the text that an algorithm can work with. There are several ways this can be done, including tokenization. This is when text is broken down into smaller units to work with. Stop word removal. This is when common words are removed from text so unique words that offer the most information about the text remain. Lemmatization and stemming. This is when words are reduced to their root forms to process. Part of speech tagging. This is when words are marked based on the part of speech they are, such as nouns, verbs, and adjectives. Once the data has been pre-processed, an algorithm is developed to process it. There are many different natural language processing algorithms, but two main types are commonly used. Rules-based system. This system uses carefully designed linguistic rules. This approach was used early on in the development of natural language processing, and is still used. Machine learning-based system. Machine learning algorithms use statistical methods. They learn to perform tasks based on training data they are fed, and adjust their methods as more data is processed. Using a combination of machine learning, deep learning, and neural networks, natural language processing algorithms hone their own rules through repeated processing and learning. There are the following 5 phases of NLP. 1. Lexical analysis and morphological. The first phase of NLP is the lexical analysis. This phase scans the source code as a stream of characters and converts it into meaningful lexemes. It divides the whole text into paragraphs, sentences, and words. 2. Syntactic analysis, parsing. Syntactic analysis is used to check grammar, word arrangements, and shows the relationship among the words. Example: Agra goes to the Poonam. In the real world, Agra goes to the Poonam does not make any sense, so this sentence is rejected by the syntactic analyzer. 3. Semantic analysis. Semantic analysis is concerned with the meaning representation. It mainly focuses on the literal meaning of words, phrases, and sentences. 4. Discourse integration. Discourse integration depends upon the sentences that precedes it and also invokes the meaning of the sentences that follow it. 5. Pragmatic analysis. Pragmatic is the fifth and last phase of NLP. It helps you to discover the intended effect by applying a set of rules that characterize cooperative dialogues. For example, open the door is interpreted as a request instead of an order. Next, let's see the techniques and approaches NLP has. Syntax and semantic analysis are two main techniques used with natural language processing. Syntax is the arrangement of words in a sentence to make grammatical sense. NLP uses syntax to assess meaning from a language based on grammatical rules. Syntax techniques include parsing. This is the grammatical analysis of a sentence. Example, a natural language processing algorithm is fed the sentence, "The dog barked." Parsing involves breaking this sentence into parts of speech, that is, dog equals noun, barked equals verb. This is useful for more complex downstream processing tasks. Word segmentation. This is the act of taking a string of text and deriving word forms from it. Example, a person scans a handwritten document into a computer. The algorithm would be able to analyze the page and recognize that the words are divided by white spaces. Sentence breaking. This places sentence boundaries in large texts. Example, a natural language processing algorithm is fed the text, "The dog barked. I woke up." The algorithm can recognize the period that splits up the sentences using sentence breaking. Morphological segmentation. This divides words into smaller parts called morphemes. The word untestably would be broken into un, test, able, and lie, where the algorithm recognizes un, test, able, and lie as morphemes. This is especially useful in machine translation and speech recognition. Stemming. This divides words with inflection in them to root forms. Example, in the sentence, "The dog barked," the algorithm would be able to recognize the root of the word barked is bark. This would be useful if a user was analyzing a text for all instances of the word bark, as well as all of its conjugations. The algorithm can see that they are essentially the same word even though the letters are different. Scikit-learn. It provides a wide range of algorithms for building machine learning models in Python. Natural Language Toolkit, NLTK. NLTK is a complete toolkit for all NLP techniques. Pattern. It is a web mining module for NLP and machine learning. Text Blob. It provides an easy interface to learn basic NLP tasks like sentiment analysis, noun phrase extraction, or POS tagging. Queppy. Queppy is used to transform natural language questions into queries in a database query language. Spacy. Spacy is an open-source NLP library which is used for data extraction, data analysis, sentiment analysis, and text summarization. GenSim. GenSim works with large datasets and processes data streams. Now, let's see the applications of NLP. Sentiment analysis. NLP is used to analyze social media posts, customer reviews, and feedback to determine the sentiment expressed, allowing businesses to gauge public opinion and make informed decisions. Language translation. NLP-powered translation systems such as Google Translate use machine learning to convert text or speech from one language to another, facilitating cross-lingual communication and information exchange. Named entity recognition. NLP helps identify and classify named entities in text, enabling applications like information extraction, document indexing, and automated data analysis in fields such as news analysis or legal document processing. Chatbots and virtual assistants. NLP-driven chatbots and virtual assistants understand and respond to user queries in natural language, providing customer support, answering frequently asked questions, and enhancing user experiences. Text summarization. NLP techniques are employed to generate concise summaries of lengthy documents, enabling users to quickly grasp the main ideas and key points without having to read the entire text. Question answering. NLP-powered question answering systems analyze text data and provide relevant answers to user questions, facilitating information retrieval and knowledge sharing in various domains, such as customer support or educational platforms. Now, when we have seen where is it used, let's see the advantages of using it. NLP helps users to ask questions about any subject and get a direct response within seconds. NLP offers exact answers to the question means it does not offer unnecessary and unwanted information. NLP helps computers to communicate with humans in their languages. It is very time efficient. Most of the companies use NLP to improve the efficiency of documentation processes, accuracy of documentation, and identify the information from large databases. We have seen the benefits it offers. But each technology has some challenges that it faces. Let's see what are the challenges faced by NLP. Ambiguity. Language is often ambiguous, and NLP systems need to disambiguate words or phrases based on context. Syntax and grammar. NLP systems must understand the rules and structure of language to interpret meaning correctly. Cultural and linguistic variation. Language varies across cultures, dialects, and regions, making NLP challenging in multilingual contexts. Data limitations. NLP models require large amounts of high-quality training data to achieve optimal performance. Now we will some MCQ question on this topic. First question is, which technique is used for converting words into their base or root form? Pause and think for the answer. The correct answer is option A. Lemmatization. Second question is, which of the following is not a common NLP task? Pause and think for the answer. The correct answer is option C. Image classification. Now let's recall what we have learnt in this session. We are able to understand about NLP and its importance. We have looked into its working and see phases involved in NLP. We have also learnt about its techniques and approaches as well as its tools and libraries. Other than this, we have looked into its applications, advantages, and challenges. Thank you. Happy learning. See you in the next session.